All right. Hello. So here we are. Assignment 4.2. So on a separate piece of paper, write down the solutions with me, get support with me. Make sure you take a picture at the end and upload it to Google Classroom. So assignment 4.2 has to do with increasing and decreasing, and connected to that is understanding local maximums and mins, critical numbers, things like that. So let's handle this one question at a time here. So assignment 4.2 says, for all these questions that you see, the next four, on which intervals is it increasing, on which is it decreasing, at which point is there a minimum, and at which point is there a maximum. So let's handle this. So these are all just looking off the graph, and pretty basic questions, honestly. So don't let this be too complicated. So I'm going to write down the answer to on my piece of paper, then I'll share it with you. So 1a, on which intervals is it increasing? So from negative infinity, and we're looking left to right, where is it rising? So from negative infinity to negative 2. We're just looking at the x coordinates. Is it increasing anywhere else? Yes. From 2 to infinity. Part B. Where is it decreasing? So it's decreasing from negative 2 to positive 2. And I'm using round parentheses when I do it. So let me just show you my work, and I won't show it. I'll show you at the end, all of it. So here's assignment 4.2. So 1a, where is it increasing? Where is it decreasing? Then the question is, where is their relative maximum? They're asking for the point. They're not just asking for the maximum value. So the relative maximum at the point is at negative 2 and 4. In part D, the minimum there is at 2 and negative 4. Let it be simple, because sometimes it won't be simple. The next one, number 2. So looking off the graph, where is it increasing? So, and notice I use parentheses when I do this. So it's increasing from negative infinity to, and notice I'm looking here, I'll use my arrow here on my computer. I'm looking here left to right, so negative infinity to negative 2. Where else is it increasing is from 0 to infinity. Where is it decreasing? So left to right going down, so from negative 2 to negative 1. So from negative 2 to negative 1, it is decreasing. Also from negative 1 to 0. And notice, you could actually technically just say negative 2 to 0 and it'd be okay as well. But I wrote them as two different intervals and have the asymptote in the middle, kind of breaks them up. But it's okay if you even went negative 2 to 0 and said that whole thing is decreasing, because it's accurate. Part C, the maximum. So there's one local maximum. It's at negative 2 and negative 4. And then the minimum is at 0, 0. So in its area, negative 2, negative 4 is a high point. And in its area, its neighborhood, 0, 0 is a low point. Number 3. Again, let this be simple. Where is it increasing? So from negative 2 to 0, it's also increasing from 2 to infinity. Where is it decreasing? Let's look off the graph. From negative infinity to negative 2, it's also decreasing from 0 to 2. Where is the maximum point? The local maximum is at 0 and 4. Where is the minimum? There's two of them, and at negative 2, 0, and at positive 2, 0. Number 4, last one like this. So number 4, where is it increasing? From 0 to infinity. Where is it decreasing? From negative infinity to 0. We have a minimum at 0, 0, and we have no maximum, so I'm just going to go. There's none. And then for part D, there's a minimum, which is at 0, 0. I'll let you see my work right now. Again, let this be simple. So there's 1, 2, 3, and 4. You can press pause and check your work. All right, next. On the first derivative number line, for the next 4 questions, answer the following. Again, increasing, decreasing, minimum, maximum. So for number 5, the increasing part So I'm actually going to draw the number line, and I'm going to label it. And then we'll go through it that way. So for number 5, you're given the first derivative number line. So for part A, I know it's increasing where it's positive. So from negative infinity to negative 2. And from 0 to infinity, it is increasing because the first derivative is positive. When the first derivative is negative, it's decreasing. That's part B, so that's negative 2 to 0. Where is there a minimum or maximum? So this is where I think it's helpful to draw little parabolas to just have a sense of it. So positive to negative, that means it was increasing and then decreasing. So if you'd show a picture of it going increasing then decreasing, you can tell that at negative 2, did it ask for the point or just the x value? Because I don't think we have enough for the point. Yeah, just the x values. Okay. So for the maximum, it's when x equals negative 2. And then for the minimum, so in this case at 0, it was decreasing, and then at 0 it changed to increasing. So if you draw a little parabola, you can visually see that at x equals 2 or x equals 0, there's a minimum. So we have a maximum and a minimum off the number line. Number 6. So again, I'm going to draw because I find it helpful to actually draw the number line. So this is the first derivative number line, negative 2, 0, and 3. And it goes negative, positive, negative, positive. All right. And the numbers listed on the number line are critical numbers. So part A says, where is it increasing? So it's increasing from negative 2 to 0 and from 3 to infinity. Where is it decreasing? From negative infinity to negative 2 and from 0 to 3. Positive means increasing, negative means decreasing. Part C, I'm going to label across here. So when it decreases and then increases, when it increases and then decreases, and when it decreases and then increases. So draw yourself little pictures here to actually visually see what's happening. So at negative 2, at 0, and at 3. So at 0, it is a maximum, but at negative 2 and at 3, they create minimums. Number 7. So again, I'm going to draw the number line. So for this first derivative number line, we have what? Negative 2, negative 1, 0. And we have plus, minus, minus, plus. All right. So in this situation, where is it increasing from negative infinity to negative 2? It's also increasing from 0 to infinity. Here, we don't have to break it up. You can just say from negative 2 to 0, it is decreasing. So because the signs stay the same. It wouldn't be wrong to write 2 intervals, but you could write it as 1 interval. Part C, where is there a minimum, where is there a maximum? For part C, maximum. So positive to negative, increasing to decreasing. Here, notice the signs don't change. So if the signs don't change, it doesn't create a maximum or minimum. And then the last one, it goes down and then it goes up. So we have one maximum, that's when x equals negative 2. And we have one minimum, and that's when x equals 0. And notice a critical number doesn't have to produce a maximum or minimum. The signs have to change. So because the signs stayed the same, it doesn't create a maximum or minimum. Number 8, we're going to draw the first derivative number line. Oh, wait a second. For number lines for the next 4 questions. All right, so let me finish this off. There's like 2 questions here, so I was just reading them carefully, trying to read carefully. So we have negative 2, 0, and 2. And then we have to see which one of these would match what we did 1 through 4. So we'll go back in a second. So let's finish this first. So, oh, I forgot to put the signs on here. So it goes negative, positive, negative, positive. So where is it increasing? That's negative 2 to 0. That's 2 to infinity. Where is it decreasing? Negative infinity to negative 2 and 0 to 2. And then I'm going to draw in here. So it goes down and then up. It goes up and then down, down and then up. So you can visually see which are the minimums and maximums. So for the maximum, we just have one when x equals 0. For the minimum, when x equals negative 2 and when x equals positive 2. Those are the minimums. Now, the next question is, which one matches with which one when I look at 1 through 4 and 7 through 8? So, let's look. So which ones could match? So negative infinity to negative 2 and 2 to infinity. Do any of these match? Well, I think they just said 7 and 8. So negative infinity to negative 2, and then it had 0. I'm looking. Which one could match? Well, first of all, I know that 8 and 3 match, so I'll do there. So if I look at number 3, in terms of increasing and decreasing, they match exactly to number 8. The x-coordinate, 0 for minimum. The x-coordinate, negative 2 and 3. So 8 and 3 match in terms of that. How about for number 7? I think number 7 matches with number 2. So negative infinity to negative 2, 0 to infinity. And then part B, from negative 2 all the way to 0. And then the x-coordinate, and then the x-coordinate here is 0. Did I miss one for number 2? I said 0 and negative 2. Well, what did I do wrong for number 7? Because I wrote down negative 2 and 0. No, it works. So number 7 matches with number 2. So if you look at number 7 and number 2, they match in terms of increasing and decreasing and maximum and minimum. So look carefully at 7, look carefully at 2, and when I look at C and D, it's the x-coordinate that matches. And when I look at B, I just treated this as one interval from negative 2 to 0, just like this goes from negative 2 to 0. All right. So one way is graphically, the other way is with the first derivative number line. All right, turn the page. Now we get to do the real good calculus work from 9 through 17. So this is the heart of what we're doing and what we need to practice. So as we practice, it's essential that eventually you need to press pause and try it first before I do it with you or for you. So the first one we'll do together, right? The number 10. But by the time we get to 11 or 12, we need to eventually have the courage, the bravery, to press pause, to try it first, and then press play and learn from this. So number 9 and on, there are the same questions I just answered, but I'm not given anything. I have to start from scratch. So let's do that here together. So we have a function, x squared subtract 8x. So the question is, I need to know where it's increasing, where it's decreasing, where the maximum and minimum points are. So let's work at that together. So step 1 is to find the critical numbers. So in order to do that, I'm going to take the derivative. The derivative here is 2x subtract 8. Then I look at two things. I look at and make it equal to 0 and see what x value makes the derivative equal to 0. So if I solve this, add 8 and divide, you can see there is one value that makes it 0, which is 4. Is there anything that makes this undefined? And it's a polynomial, so all values work. Nothing makes it undefined. So this is the only critical number right here at x equals 4. So then what do I do? Well, I just draw a number line, and it's a first derivative number line. The only number I need to put on the number line is 4. You don't have to go negative infinity to positive infinity. You need to know that, though. And then I substitute in to the derivative to see if the answer is positive or negative. Now, what do you substitute in? Well, you have a choice. And you can pick any number smaller than 4 and then any number bigger than 4. So if I'm going to pick a number smaller than 4, I'm going to pick 0. And if I plug in 0, I get a negative answer. If I look at a number bigger than 4, I could plug in 1 billion, and you can easily see the first derivative after 4 is positive. So here's our number line. Now we can answer the questions we need to answer. So in part A says, where is it increasing? And the answer is 4 to infinity. Where is it decreasing? From negative infinity to negative 4. Where is the local maximum? Well, at 4, we decrease and then increase. So at 4, does it create a maximum? No. So there is no maximum. In this case, there's only a minimum. And the minimum is when x equals 4. Now, I think it asks you for the point. Let me just make sure, and not just the x coordinate, and it does. So then, how do I find the x coordinate or the y coordinate that goes with that x coordinate? And we come back here at the beginning, and I plug 4 in and solve it. So in this set, it is 16 take away 32, and now you have the y coordinate that goes with it. So we have a minimum at 4, negative 16. There is no maximum, and here are my intervals. Done. That's at the heart of what we're doing, and a simple example of what we're doing. Number 10. Let me write that down. So at number 10, again, we have a polynomial. This is negative 2x squared plus 4x plus 6. Now, you know enough about parabolas that the vertex in a parabola will either have a maximum or a minimum and not both. So when we do the work, it's either going to be a maximum or minimum. In fact, because you know parabolas, because the a equals a negative number, you already know that what you're finding is a maximum value and that there's no minimum value to find. Because a is negative, you know the picture of what the parabola is going to look like. But anyway, step 1 is to take the derivative. So 2 times negative 2 and then 4. Make it equal to 0 and solve it. So I'm actually going to add 4x and then divide by 4. So at what x coordinate do we have a critical value? There are nothing that makes it undefined, so that is the only critical value. But I do label to make sure I understand that's a first derivative number line. Then when I substitute in here, I'm going to substitute in left and right. So pick a number less than 1. How about 0 into the derivative? So plug 0 in, and all I care about is the answer is positive or negative. Now pick a number bigger than 1, like 1 billion. And notice that's going to make the answer negative. Now we can answer the question. So in part A, where is it increasing? So it's increasing from negative infinity to 1. Where is it decreasing? From 1 to infinity. This, what does it create? Remember, we even said it. It increases, then decreases. So at x equals 1, there's a maximum. To find the y coordinate, I'll do that underneath. I plug 1 into the function, not the derivative, to find the y coordinate. So this is 10, take away 2. So we have a maximum at 8, and we have no minimum, just a maximum. Number 11. Do you feel you want to try it yet? Let's see. Number 11. I think you can try this one. So if you have the courage, write down the question, press pause, and try it. Tell me where it's increasing. Tell me where it's decreasing. Tell me where the maximum and minimums are using algebra and calculus. We can do it. So if you press pause already and tried it, here's the answer. So did you take the derivative? So the derivative here is 6x squared plus 6x minus 12. Make it equal to 0. I'm going to factor out. Actually, I'm going to divide 6 everywhere. So if I divide everything by 6, I get 1x squared, 1x minus 2. And then I'm going to factor this. Get this arrow here. So if I factor this, it's x plus 2. X minus 1. So the first factor gives you the answer negative 2, and the second one positive 1. We also need to know, is there anything that makes this derivative undefined? No. So now we're going to draw a number line. So I'll do that over here. So on this number line, I now have 2 numbers to put on it, which is, and I'm going to put them in order, negative 2 and 1. Then I'm going to pick a number in the interval and test them to see if the answer is positive or negative. I'm going to use the factored form of the derivative because it'll be easier. So I'm going to plug in a negative number. So if I plug in negative 3, you have a negative times a negative. That answer is positive. If I plug in a number between negative 2 and 1, like 0, if I plug in 0, I get positive times a negative, which is negative, and then plug in a number bigger than 1. And if you do that, like 3 or 2, a positive times a positive, which is positive. On here, I'm going to label it. So that's my first derivative. If I go increasing and then decreasing, or decreasing and then increasing, I can tell what I found from my number line. So part A is, where is it increasing? So it's increasing from negative infinity to negative 2, and from 1 to infinity. Where is it decreasing? From negative 2 to 1. Is there a maximum? Yes. And the x-coordinate of that is at negative 2. I'll find the y-coordinate in a second. Part D, is there a minimum? Yes. And that's when the x-coordinate is 1. So I need to find the y-coordinates that go with it. I don't go to the derivative. I go back to the beginning to the function. So I'm going to first plug in negative 2. So 2 times negative 2 cubed, 3 times negative 2 squared, and then negative 12 times negative 2. See if I can do this without a calculator. Negative 8 and 2 is negative 16. 4 and 3, that's 12. And then that's a negative times a negative is positive. So I can see negative 4 and 24, that's 20. So where are we at? Negative 2 and 20 is a maximum. Now for positive 1, that's 2 plus 3, take away 12. So 5 take away 12, that's negative 7. And you found your maximum and you found your minimum using calculus and algebra. Number 12. Number 12, it looks bad worse than it is. So for number 12, we have 3/5 x to the 5/3 minus 3 over 2 x to the 2/3 plus 1. So I believe you can do this. So I want you to press pause and tell me 4 things: increasing, decreasing, maximum, and minimum. Go for it. Then press play. All right, so for those that went for it, here's your reward. You get to sit and relax and see that you did it correctly. So when I go 5/3 times 3 over 5, the 3's divide out, the 5's divide out, you just have 1x. Then I'm going to subtract the exponents. So 5 over 3 take away 1 is like 5 take away 3. That's positive 2/3. Were you able to get x to the 2/3? Next one. Same thing happens. 2/3 times 3 over 2. The 2's and 3's divide out. You're left with negative 1x. And then I'm going to subtract 1. So 2 take away 3 gives me negative 1/3. And then the derivative of 1 is 0. So there we are. Next, I need to find the critical values. Now, I already know one critical value. In fact, I'm going to tell you that if we can change this, this is very calculus friendly. To be more algebra friendly, I'm going to not write it with fractional exponents. So this is the cube root of x squared, and this is 1 over the cube root of x. So if I don't write it with fractional or negative exponents, you can first see that one critical number, I'll put that over here, critical number is already at 0. So why is 0 a critical number? Because if I plug 0 into the derivative, it's undefined. So if there's a value that makes the derivative undefined, it's a critical number, and I see it at 0. Next, I'm going to make it equal to 0 and solve it. So we have the cube root of x squared. I'm going to add to the other side, so this fraction then goes to the other side. And now I want to solve this. I know it looks a little complicated, but I'm going to treat this, and I'm going to multiply both sides by the cube root of x. Now, by doing that, it's equal to 1 over here. A cube root times a cube root. So this is like x to the 1/3 times x to the 2/3. And so when I multiply, I add the exponents. So when I go 1 plus 2, it's 3 over 3. Remember, you're adding exponents when you're multiplying and the bases are the same. So when I add this together, I get 3 over 3. I get x equaling 1 as my answer. See what's left in the exponent. I know it's challenging. Look at the exponents. 1/3 plus 2/3 equals 1. And so when I bring it together, x to the exponent 1, or just x, is equal to 1. And when I plug 1 in, it actually solves it. 1 to any exponent equals 1, and 1 times 1 equals 1. So there you go. So you have the second critical number, which is at positive 1. All right, now we can draw a number line. So I'm going to do that up here. So first derivative number line, and I have 0, and I have 1. Now, when you pick a number here, pick a number less than 0, and you're going to go into the derivative. And all I want to know if the answer is positive or negative. I want you to recognize that no matter what you plug in here, that answer is always going to be positive. And whatever I plug into here, a cube root keeps its sign. So if you plug in a negative, it stays negative. If you plug in a positive, it stays positive, just so you know. So this will always be positive, because any number, when you square it, will be positive, and then you cube it, cube root it. When you cube root a number, even though it's in the denominator, it keeps its sign. So if you plug in a negative number, it stays negative. Plug in a positive number, it stays positive. Okay, so plug in a negative. So you can have a positive. Here, this is going to stay negative, but the negative in front, a negative times a negative makes it positive. And so that makes that positive. Plug in a positive 1/2. That's a positive. Positive 1/2 stays positive, but we have a minus sign. So now it's a matter of which one is larger to know whether the answer is positive or negative. A little bit tricky. So let's do this on the side here. So if we have 1/2, I just want to know whether the answer is positive or negative. So the first one, recognize that the 2 means you square it and then cube root it. Here, for the negative exponent, you're going to have to do the reciprocal. So for the reciprocal, you end up with 2 to the positive 1/3. So when I look at each one, which one is the larger number between the two? The second one is, right? So a positive here is not there. So that's going to create a negative between 0 and 1. So sometimes it takes a little bit of work to get there. And then when you plug in a number bigger than 1, like 1 billion or something like that, which one's going to be the larger number as we do that? And recognize here, when you go 1 billion and you square it and cube root, it's going to be bigger than the fraction that it creates. This one's going to be positive. I know it takes some work to plug in a number, and when you only care about is if the answer is positive and negative right now for that derivative. So first, part A, where is it increasing? So from negative infinity to 0, and the second part is from 1 to infinity. Part B, where is it decreasing? From 0 to 1. Part C, here we have a maximum and here we have a minimum. So at 0 we have a maximum, and at positive 1 we have a minimum. So we have to go back here. So 0, 0 leave me just with 1. Now the good news about 1 is 1 to any exponent is 1. So if I want to know when I plug in positive 1, you're left with 3/5, take away 3/2 plus 1. Yes, you can. So we're going to make the common denominator 10. So multiply it times 2, multiply it times 5, and then 10 over 10. So 6 take away 15, that's negative 9, plus 10 is 1. So that's 1 over 10. So we have a maximum at 0, 1, and a minimum at 1 and 1/10. Let me just double check to make sure I did that okay. So 1 and 1/10 is the, I think they have it mixed up there. Or maybe I do. No, 1 and 1/10 is the minimum, and 0 and 1 is the maximum. So I just think the answer key there have it mixed up. It's clear that 0 is the maximum, and at positive 1 is the minimum. So sometimes answer keys get it kind of flipped around too. Oh, what do I want to do? All right. What question are we on? Number 13. So x cubed plus 1. So I'm going to promise you one thing. Number 13 is far simpler than number 12. So I think you can definitely press pause and try number 13 because it's far simpler than number 12. So we got through number 12 together. Try it. All right, so here's a reward for those that tried it. The derivative here is just 3x squared. There is nothing that makes it undefined. If you make it equal to 0 and solve it, there's only one answer, that's 0. We're going to do a number line. So for the first derivative number line, the only critical value is 0. So plug in a number smaller than 0. So, I mean, you can tell here. So if you plug in a negative number, the answer is positive. You plug in a positive one, it's positive. So what did you notice? There's no sign change. And because there's no sign change, there is no maximum and no minimum. This is what's called monotonic. That means it's only increasing from negative infinity to positive infinity. So it's increasing everywhere. It is not decreasing. There's no maximum, and there's no minimum. So this is the only information we can get. Now something is happening at 0. It's a point of inflection, but there is no maximum or minimum happening there. So where is it increasing and so on? See, it was a lot easier. Number 14. All right, so step 1 here. Do you want to try it first? You can press pause and try it, or you can work with me. So the derivative here, that's the bottom times the derivative of the top. That's 1, so I'm not going to put there. Then the top times the derivative of the bottom, and then the whole bottom squared. So the best I can do here, this is x squared subtract 9, subtract 2x squared. And I think it's going to be helpful to factor the denominator. So x plus 3, x minus 3, all squared. And then the last step that's going to be helpful is to combine like terms on top for the derivative. So negative 2x squared plus 1 is negative 1x squared. Subtract 9. Oh, that's interesting. Let's see if that's true. So if I do this, no, it's not what I think. Okay. Oops. I just erased everything that I want to do here. So let's try it again. So negative 1x squared subtract 9. I thought maybe if you factor out a negative, it would help factor, reduce it down, but it won't. So it would end up with x squared plus 9, which is not factorable. Okay. So where are the critical values? So there's the derivative. So the critical values is what makes it undefined and made it equal to 0. So where is it undefined? I need to look in the denominator. What two x values make it undefined? So I want you to notice that negative 3 and positive 3, both of those values make the bottom 0, which makes it undefined, which makes it a critical number. In the numerator, let's make that equal to 0 and see what happens. So I'm going to add x squared. And I want you to notice I get x squared equals negative 9. Well, x squared can't equal negative 9. And you square any number, it's going to be positive. So there's no value that makes the numerator 0. So the only critical numbers are here, and they're actually at the asymptotes. Those are the only critical numbers, negative 3 and positive 3. So let's draw a number line. So recognize, because only at the asymptotes are there critical numbers, we have no maximum and no minimum, because these are asymptotes. They're not points. They're not x coordinates for points. So I can find increasing and decreasing, but there is no maximum point and minimum point, because these are not points, because it makes the function undefined. Those are asymptotes. So these are asymptotes, so I can find increasing and decreasing, but I can't find any points, because these x values make the function undefined. There's no points at these. These are asymptotes. Okay, so pick a number smaller than negative 3 and plug it in and see what happens. So I want you to notice that no matter what number you plug into the numerator will always be negative, and no matter what you plug into the denominator will always be positive. You always have a negative over a positive. All of these are going to be negative. So no matter what number I plug in, you plug in a negative number, you square it, becomes negative, subtract 9, 0, positive. This will always be negative. The denominator, whatever the number is, and you square it, will always be positive. So you have a negative divided by a positive all the way through. So what does that tell you? First of all, where does it increase? Nowhere. Where is it decreasing? Everywhere. And it's okay to say negative infinity to positive infinity. It's monotonic. Everywhere it's decreasing. Part C, where is the minimum or maximum? Well, there is none, because we have no sign changes. So we have a monotonic function that's only decreasing. It has no turning points. Number 15. Let's just make sure we did that correctly. See if the answer key is right. Number 14. See, negative, negative, negative. All right. Let's look at number 15. X plus 1 to the 2/3. So I want you to press pause and do your best to do it first. So again, we're looking at where is the function increasing, where is it decreasing, where are the local maximums and minimums using calculus and algebra. All right, for those that did the work, you can sit back and look at the video to see if you did it correctly. So take the derivative, that's 2/3, x plus 1, subtract 1 from the exponent, that gives you negative 1/3. Notice the base, you would have a chain, but the denominator, x plus 1, or the base, when you take the derivative of x plus 1, it's 1, so it doesn't change the value when you go times 1. So it's not necessary. So that's the entire derivative. So I think, again, it's helpful to not write it as a negative exponent or a fractional exponent. So I'm going to rewrite it. We have a 2 in the numerator and a 3 in the denominator. X plus 1 has a negative exponent, so it goes in the denominator. And I'm still going to write it as 1/3 or the cube root. So that's a more helpful form to see the critical values. So where do we have any critical numbers here? So in the denominator, negative 1 makes the denominator 0, because negative 1 plus 1. In the numerator, I don't even have a variable in the numerator, so there's nothing that makes it 0. So the only critical value then is at negative 1. Now, if you look here, negative 1 is a point. So at negative 1, you actually get a value. It's not an asymptote. So negative 1 can be a turning point, just to let you know. So only negative 1. Now, when you look here, plug in a number smaller than negative 1. And when I look here, because I'm squaring it, any number I put in here will be positive. And on the other side, any number I'll put in there will also be positive. So therefore, at negative 1, the signs don't change. And because the signs don't change, it's monotonic, there's no turning points. So for A, it's increasing everywhere. And then for everything else, it doesn't exist. So there's no turning points and it doesn't decrease. So again, let's make sure we did it correctly. There's that one for 15. Did I pass it? Of course I did. Right there. Oh, it said negative and positive. What did I do wrong? I know what I did wrong. So let's go back again. That's why I double check my work. Sometimes the answer key's wrong, sometimes I'm wrong. I didn't see something. So here we go. So maybe you saw it and I didn't. So what happens is that I plugged it into the wrong one. I plugged it into the function and not into the derivative. I'll be smarter. So when you plug in a number smaller than -1, like -2 or 3, this ends up being negative. Because a negative number you cube root, it keeps its sign, so it makes the whole thing negative. When you plug in a positive number, a number bigger than that, even like 0 or any number bigger than -1, everything would be positive. So we have a negative to a positive. So that means B and A, let's correct everything. Everything's wrong. So part A, where is it increasing? -1 to infinity. Where is it decreasing? From -infinity to -1. Where is the maximum? Well, this here creates a minimum. Goes down and then up. So this one actually was the only one that was right. The last one, where's the minimum? -1. What happens when you plug -1 into here? -1 plus 1 is 0, and 0 to anything is 0. And so at -1, 0 is a minimum point on our graph. Number 16. Where is it? Here it is. So we're going to do 16 and 17, and then we'll end at 17, and then I'll do a second video after 17. All right, number 16. And it's not about making a mistake. It's about having the courage to try it, right? To take your shot, to see if you can make it happen. So I want you to pause and try your best, and then come back and see if we did it right. All right, for the ones that did their work, you can sit back and see if you did it correctly. To take the derivative here, I need to use the quotient rule. That would be the denominator times the derivative of the numerator, which is 1, so I don't need it. Then the numerator times the derivative of the denominator, 1, I don't need it. And then take the denominator and square it. Combine like terms. So x subtract x, 1 subtract -1. So be careful there. That's 2, not 0. So it's 2 over x plus 1 squared. That's what I'm looking at. Where's the only critical number there? So the only critical number is when x is -1. Because when it's -1, it makes the denominator 0. And I want you to notice here for the function, -1 makes the function undefined. So if it makes both undefined, it can't be a point, and it can't be a turning point. So all I can find are increasing and decreasing. No turning points. So draw a number line. Only -1. Use the derivative, right? Not this. I want you to notice that you have a positive number on top. And the denominator, whatever number you plug in, you're squaring it. Do you have this number sense to know that no matter what number you plug in, the answer will always be positive? That's what we need to build and have the confidence of when doing this. So this is monotonic. Both sides are positive. So part A, everywhere. Oops. B, C, D, So because it's monotonic, it's increasing everywhere and none of these other things happening. So let's see if I'm right or if I need to correct myself. I think I'm okay. So this is again for number 16. So for number 16, and notice they have at -1, they created 2, but you don't need to. So you can go -infinity to positive infinity, saying it's increasing everywhere, even though exactly at -1 it's not defined. And then you can see there's no values for B, C, or D. All right, last one for this video, number 17. So let's write it down. And again, I want you to try it. It's not too bad, I promise. So this is one I know is accessible for most of you, and I want you to take a shot. I want you to try it. Press pause and do your best. Or again, for those that tried the work, here, let's sit back and see that you did it correctly. Take the derivative. 4x cubed subtract 6x squared. There's nothing that makes this undefined. Make it equal to 0 and solve it. I'm going to factor out a 2x squared, and that leaves me with 2x subtract 3. Factoring. The first factor gives me the answer 0. The second factor, you would add 3 and divide by 2. So we have two critical numbers, 0 and 1.5. I'm going to draw a number line for the first derivative, 0 and 1.5. Then, make sure you don't make this mistake. Go back to the derivative. And usually the factored form of the derivative is the easier one to see whether the answer is positive or negative. So plug in a negative number. So that's a positive times a negative. That'd be negative. Between 0 and 1.5, pick 1 because it's the easiest one in that interval. So positive 1, positive, and a negative. And then at 1.5, pick any number bigger than 1.5. And that will, into the derivative, will give you a positive answer. So notice at 0, the sign didn't change. No turning point. At 1.5, it did. So at 1.5, we go down and then up. It's a minimum. So at A, where is it increasing? From 1.5 to infinity. For B, where is it decreasing? From negative infinity to 3 over 2. So all the way it's decreasing. At part C, do we have a maximum value? No. At part D, do we have a minimum? Yes. At 1.5 or 3 over 2. And then how do I find the y-coordinate? Probably the hardest part of the problem is finding the y-coordinate of the minimum. So here we go. We'll do it together. So that would be 3 over 2 to the 4th, and then 2 times 3 over 2 cubed. And the answer is yes, you can do this if you had to. So 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81, 2 to the 4th is 16, 3 times 3 times 3 is 27, 2 cubed is 8, so 81 over 16, this is 54 over 8, multiply times 2, that's 108. So it's 81 subtract 108 over 16. 81 take away 108 is a negative answer. Was it negative 19 and negative 8? So negative 27. So it's negative 27 over 16. And of course I'm going to check to make sure I did it right. So this is for number 17. So let me check my work. Looks good. And again, maybe I got C and D where they said minimum and then maximum, and they switched it up from the other question. Maybe that's the thing is. But anyways, this is a minimum, and the none goes with the maximum. So I think maybe C and D is mixed up, which is fine. Don't change it. You can take a picture of what you got. Let me see. So when it asks, so it first asks for a minimum and then a maximum. So there you go. And then up here it asks for a minimum and then maximum. Did I always get that minimum and then maximum? So my brain was just going everywhere. But listen to my words, not in terms of like A, B, C, and D, in terms of that. So you don't have to redo it, but just know which one goes with which one. So we're going to end this video there at 17. Recognize that we just found there for this one was a minimum and that there was no maximum, even though I've been switching C and D around for most questions. But it's okay, don't redo it. And I'm proud of you that you're doing your work. I'm hoping you're pressing pause. I'm hoping you're trying your best, because that's all I can care, right? All I can ask for you is to give your best effort and keep growing with me and understanding calculus and algebra and how it all fits together. So until next time, Mr. G Math, over and out.